Hi everyone, today we'll be doing a question I made about tangent lines and the unit circle, and yeah, let's jump right to it. So it says a line is tangent to a unit circle centered at its origin, and a radius drawn from the point of tangency to its center creates a 30-degree angle between the x-axis and the radius. Find the equation of the tangent line. This is supposed to be tangent line, just to make sure. Okay, now this is like more of a word problem, and it's really helpful to draw a diagram in these cases. So I would try, actually I can probably draw a really good circle. Oh, can I just make it a simple circle with no text? Okay, so let's say this is our circle. Oh no, this is our circle on our unit plane, like that. Okay, and then we know that once at the point of tangency, so let's say it's tangent right over here. When you draw a radius, the angle over here will be 30 degrees. Okay, and then we are tasked to find a line that's tangent to this right here, something like that goes like down here-ish. Let me just draw a better one. That'll work. Okay, so we want to find this entire equation, so it'll be in the form y equals mx plus b, your regular line. And the way that we can do this is that by knowing that the point of tangency means that the radius and the tangent line are perpendicular to each other at the point of tangency. We can find the slope of the radius and take the negative reciprocal of that slope to find the slope of the tangent line, because again the negative um reciprocal, I'll just denote it by 1 over whatever random constant k, will give you the slope for perpendicular. Slope of perpendicular. That'll be perpendicular. Okay, so how do we find the slope of the radius? Well, it is rise over run, right? So it'll be rise, or this y value, divided by this x value. And in a unit circle, the y value and the x value are sine and cosine respectively. So in other words, when you want to find the radius of the slope of the radius, you want to do sine theta over cosine theta, because again it's y over x. And we know that sine theta over cosine theta is the same thing as tan theta. Tan theta. Okay, so if tan theta is a slope of whatever radius we have, then the slope of our line for our tangent line will be -1 over tan theta. Okay, so that is equal to our m value, and y equals mx plus b. Now, how do we find b? Well, we can find b if we know one of the points on the line, which we do actually. We know that the point of tangency lies at the end of this radius, which is 30 degrees lifted from this axis right here. And we know the value of this because, again, our sine and cosine values. This point over here, x comma y, is the same thing as cosine 30 comma sine 30, which is root 3 over 2 comma 1/2. Okay, so now we have everything that we need. Now we just have to put it together. We can figure out that tan theta is equal to, again, using our sine and cosine values, 1/2 divided by root 3 over 2. which is the same thing as 1 over root 3. And then because it's negative 1 over, because our value of m is negative 1 over root 3, we can just rewrite this as negative root 3 is equal to our m value. Okay, so now we have our m value. We can write y is equal to negative root 3x plus b. Well, now let's plug in our point right here to find the value of b. Let's bring this equation over here because there's more space. Y is equal to negative root 3x plus b. And then we can say our y value, which is 1/2, is equal to negative root 3 times root 3 over 2 plus b, which will just give us 1/2 is equal to 3 over 2 plus p. When you add 3 over 2 on both sides, you get 2. So our final answer will be y is equal to can't forget the negative root 3x plus 2. There you go. Alright, thank you guys for listening, and let me know what you guys think of it in the comments. See you.